Hello students, I am Dr. Sanjeev Punia. In last lecture of computer arithmetic, we discussed about addition in computer arithmetic. We discussed and generalized that how we can design a circuit when we have different numbers for the addition. Let us summarize first that we study in last lecture. So from this table, we can see that in case of addition, these are four cases we discussed last time. These are four cases for the addition. So in this, both the numbers are positive, both the numbers are negative, one number is positive and one number is negative. So these are the different possible cases those can be. So when first of all we have to check the sign of both the numbers. It will depend on that. If the sign of these numbers, as here is also plus, here is also plus, here is also minus, here is also minus, then we have to do a plus b, means we have to add the number, and sign is the sign of any number a or b because these are same. When these are different, when both numbers sign are different, then we have to check the magnitude of these two numbers a and b, and result has to be find out by subtracting less magnitude than more magnitude, means small number than big number, and sign of the result will be the sign of a if a is larger, and sign of complement of a, that is sign of b if a is less than b. And when both are same, then result will be 0, that is plus 0. This discuss we in the last lecture, and we saw one example also based on this. So this is the summarization, that first we have to check the sign, then they are same or different, because the algorithm or the design whatever we are going to make for the negation, for the subtraction, that is also based on addition, means this is the addition, and we have to modify little bit of the additions circuits or algorithms to change it into the subtraction algorithm. So try to understand it, that when we have to add the number, then first of all we have to check the sign of both the numbers, that can be same or that can be different. This same case will come in the subtraction also. This is the reason that I am explaining you addition once again. So first check the sign, as we are checking over here, same we will check in subtraction also. So when the sign of two numbers are same, then magnitude is a plus b, and sign is either of a or of b. This is the case when the sign of both the numbers are same. The reverse of this will be happen in the case of subtraction. Means the sign of the numbers are different, then this is equivalent to the sign of same in the addition algorithm. Means whatever is happening over here for the same, in subtraction that will perform for the different one, and here whatever is the operations going to performed for the different sign, that operation will perform as the same over there. So these two will be depend on each other. So this is the reason that we are trying to understand this once more. So when both the sign are different, in that case, we have to compare the magnitude of both the numbers, and magnitudes of both the numbers can be different or they can be same. When they are different, then we have to subtract the smaller number only and only magnitude. We are not talking about the sign bit. We have to subtract only magnitude of a number from the another. So we have to subtract the smaller number from the bigger one, and the sign of that will be A if sign of A or the A is bigger. When A is bigger and we are getting the result A minus B, then in that case the result sign will be the sign of A. It means when A is greater than 0, and second case it will be complement of A when A is less than B. And when both the magnitude are same, in that case magnitude will be A minus B, that is 0, and sign will be positive. We discuss this example also based on that. So today we will start subtraction algorithm. So the table that we discuss first over there, I am discussing the same table again. Over there we discuss this for the addition. Now we will discuss this for the subtraction. So these four operations are corresponding to subtraction. So there are also four possibilities that when we have to perform the subtraction, these are the subtraction. When we have to perform the subtraction, then the sign of both the numbers can be same. As you can see over here, this is plus A, this is also plus A, this is minus A, and this is also minus A. The sign of both the numbers can be different, as it is plus with A, minus with B, and over here minus with A and plus with B. So from here you can see that when both the when both the sign are different, this is plus and this is minus, this is minus and this is plus, then we have to add two numbers. We have to find the subtraction by adding A plus B, by adding both the numbers, and sign of the number sign of the number will be the sign of the A, and in this case also it will be sign of A. When both the numbers sign are same, that is either plus or minus, in that case the subtraction of both the number is going to be calculated by the magnitude of A minus magnitude of B, and the sign of result will be equals to sign of A if A is greater than B, and this is complement of A if A is less than B, and if A is equals to B, then it will be 0, that is A minus B with a positive sign. So from this table you can analyze it very well, that whatever it is happening over here, in case of same, these are is same, this is same. In case of plus, this is A plus B and A plus B. But here when both the numbers are different, means the sign of both the numbers are different, in this case we are finding the result by adding these two numbers A and B. So this is the complementary of addition. So this was the reason I was telling that the rules of addition will be used over there in subtraction, and it's really easy to understand and we can implement it in subtraction. So here, if I want to find out or generalize this with an example with an L row, then as we saw in case of addition also, over here also, first we will see the sign of the magnitude. So the sign of both the numbers, when the sign is different, in that case magnitude is A plus B and sign is the sign of result. As the previous table you can see that when these two are different, this is plus A, this is minus B, this is minus A, and this is plus B. In that case, this is A plus B, and result is equals to the sign of A and sign of A. So this is the case when both the numbers are different, and when both the numbers have sign same, then we have to compare again the magnitude of both the numbers, and these are two possibilities, that after comparing the magnitude can be different or it can be same. So when the magnitude is different, then result is going to be found out by A minus B. That is, we have to subtract the magnitude of a small number from the bigger one, and sign is equals to A if A is greater than B, and it will be complement of A if this is less than B. And if the magnitude of both the numbers is same, then magnitude will be 0, that is A minus B, and sign will be positive. This is this looks like same as in the case of addition. In case of addition, here it was same, it was different. This was the basic difference between the subtraction and addition. Means these two, addition and subtractions, are complementary to each other. So when we have to design the circuit for this, we have to take the complement. So now we will try to solve a question based on this to verify that this is working properly or not. So this is an example for subtraction. Suppose I have two numbers A and B, where A is +3 and B is -2, and we have to subtract this. When we have to subtract, then I said you first we have to check the sign bit of the numbers. In this case, sign bit are different, so we have to add these numbers. We have to perform A plus B. 3 is equals to 0. This is the sign bit. It represents positive. 0, 1, 1, and -2 represent 0, 0, 1, 0. So according to the rule, we have to perform this. We have to add the magnitude of these two numbers. So the result should be, this is 1 plus 0 is 1, 1 plus 1 is 0, and 1 is carry from here, and this is 1 plus 0 is 1, and with a sign plus, as it is told over there that the sign of the result will be the sign of A. This was from that concept. Now I want to tell you that how it happens inside the computer, or what the, by using the process that we studied by taking the 2's complement. I have to subtract +3, and this is -2. It means I have to subtract -2 from +3. So 3 can be represented as, this is 0 sign bit, and this is 0, 1, 1. When we have to write -2, that first we have to write 2, that is +2, and as it is +2, so first bit sign bit will be 0, and rest of the bit will be 0, 1, 0. So this is the binary equivalent of +2. Now I have to write -2. So to write -2, we have to write the 2's complement of this. So 2's complement of this, by using direct technique, as I told you, that we have to start from right. So start from right. This is 0, so write it as it is. This is the first one we get. Write first one as it is, and after that flip 0 into 1 and 1 into 0. So this 0 will change into 1, and this 0 is also going to change into 1. But till This point we solve this question till here only. We find -2. Again, we have to find out the 2's complement of this. Means we have to again find the minus of -2, that is 2's complement of 2, and this is equals to again 0. This is first one, write it as it is, and again change the values from 0 to 1 and 1 to 0. So now this is the 2's complement of -2, and we have to add this number in +3. This is equivalent to +3. So we are adding these numbers. This will be 1 plus 0 is 1. 1 plus 1 is 0 with a carry 1. This is a carry 1, plus 0 plus 0 is 1, and 0 plus 0 is 0. So from here you can see that the number is positive and it is equivalent to 5. From here also you can see that we are doing +3 minus -2, and we know that minus minus becomes plus. Minus minus became plus. So this minus will cancel each other. So we have to do +3 plus 2, means we have to add these two numbers. So this is +5. So the thing we studied in the last, that has to be proved now. In second case, this was the case when both the numbers were different. As I told you over here that when both the numbers are different, in that case we have to find out the subtraction. But when both the numbers are same, in that case, first of all we have to compare the magnitude. So let's come on second number. In second example, this is +3 and this is also +2, means two, the sign of two numbers are same. Means now we have to apply the second rule, and the rule tells that when both the numbers are same, then we have to check the magnitude of both the number first. So a is equals to 3 over here, or the magnitude of a is 3, the magnitude of b is 2. Here the magnitude of b is 2. So we have to find out the value by a minus b. A minus b. And a minus b is equals to 3 minus 2, that is 1. And now we have to check the sign, that the sign should be plus or minus. Now this is shown that when the value of a, when the magnitude of a is greater than magnitude of b, or when a is greater than b, in that case the sign will be a, the sign will be a. Sign of a is plus over here, so the value will be +1. You can see from here also that this is +3, this is +3. So when I'm doing this +3, means sign bit is 0, it represent plus, and it is equivalent to 3. And when I have to write -2, means +2 is equals to 0 0, 1, 0, and we have to take 2's complement of this number to find the 2's complement. So this is 0, 1, this is 1, and this is 1. So now we have to add these. So this is 1 plus 0 is 1, 1 plus 1 is 0 with a carry 1. So here is a carry 1. So 1 plus 0 plus 1 is 0 with a carry 1, and this is carry. So 1 plus 1 is 0 with a carry 1. So from here you can see that this is the sign bit. So it represents that the number is positive. Leave this at this case because this is overflow. This is overflow, and this is not our purpose to discuss overflow at this time. We discussed overflow earlier. So this is the basic behind addition and subtractions. Now I want to design a hardware for addition as well as subtraction. As I told you that these are complementary to each other. So what I can do that if I have to add two numbers, then I can add directly. Suppose I have 4-bit number and I have another 4-bit number, then I can add using parallel adder directly. But when I have to subtract the number, then what will happen? We know that we cannot subtract the number. To subtraction or to perform subtraction, we again have to add the number, but by taking 2's complement. So when we have to subtract b from a, then in that case first we take the complement of a, and then we add this number with this number. So when m is equals to 0, it means it is working as a adder, and when m is equals to 1, it means then the circuit is working as an subtractor. So this is the basic concept behind the circuit design of addition and subtraction. Now we will see the flow diagram or flow chart over here. So in this, E contains the output carry, the final carry of the result of the addition or subtraction. AS represents the sign bit of a number A. BS represents the sign bit. This BS represents the sign bit of number B. And A, if the value in AVF is 1, then it is overflow. So this is the concept behind circuit design. Now flowchart of addition and subtraction, as I told you that by using one circuit we can implement this. So we are using addition and subtraction in the same path. Only we will check over here that this is for the addition or this is for the subtraction. I told you that first we have to check the bit of the sign. So from here we can decide that we have to add or subtract. In the case of subtraction, as I explained you, that when both the number sign are different. So in this case, when both the number sign are different, in this case that is equals to 1. That is equals to 1. Means in this case, it will perform as a plus b. A plus b means same as the addition. And when in this both the values are different, means sign of both the values are different, then this is equals to 1. It means it will perform the functions of subtraction. As I told you that these two are working complementary, so we have to decide that it will work as subtractor or an adder. So this was the basic concept behind this. Generally, in the exam, they ask about the flowchart of addition and subtraction, or maybe sometimes they give the question and we have to solve that question based on this one. So I think this is sufficient for today. Thank you. In the next class, we will discuss about the multiplication. Thank you.